All right, there we go. Remember to turn on the record, because yeah. So we're going to be finding areas of triangles. And we can use this formula up here to do this. This is, you know, the standard triangle formula we know, 1/2 base times height. So if we think about it this way, we have our 1/2, whoa, wrong pen. 1/2 base, this is the base. So that's this guy down here, side A. And what this chunk is the height. If we, what's up? Oh, love that. So much fun. There we go. Yeah. No, tell me if I do crazy things like that. Love that. All right. So I will rewrite this part so we can see it. So our A is the base. Bless you. Drama. Oh my goodness. And then if we drop a vertical line here that is perpendicular, that's our height. The way it shows up at this is actually if we use law of sines. So the way we get height to be this uses law of sines, because we could set up the height over angle C. It's all opposite of this angle. So the sine of gamma. And if we know side B, we could do B over sine of, looking at this little right triangle here, 90. What is sine of 90? 1. So if we want to get h by itself, oh, sorry. What's up? So if we want to get h by itself and solve for our height, oh, that's where the thing went weird. It moved a button on me. There we go. I love when they update things and don't tell me it's an update. One of the buttons I use all the time to change it so you don't zoom in with me. Accidentally hit a stop there in my way. Love that. So if we get h by itself here, sine of 90 is 1. So that height, that vertical line there from my A angle to my side A is B sine of gamma, which is exactly what we see in that formula. So we can use our law of sines on these little triangles in order to figure this out, or we can memorize this, either way. But that's where this piece comes from. It is the height. So we're going to use this to find areas of triangles today. We're going to find areas of triangles actually in a couple of different ways. Because of course we are. Naturally. All right. So here we're going to be given a triangle and we're given some information. We've got our gamma, side A, and side B. So I know that this angle is 143. That is a trash 4. Trying that again. There we go. 143 degrees. I know side A is 7 meters and side B is 18 meters. That is not side B. There we go. So what we're going to do is we're going to use this new area formula we have. We don't have to draw a triangle for it. We can just use the formula, but I feel like it helps us see what's going on here. Helps us see stuff. So we're going to have that our area is 1/2 side A, our base, which is 7, times B, our other side, 18, and sine of the angle between them. Sine of the angle between, which is 143. These are always going to be the two sides that touch this angle. And we can type this in the calculator. So we have 1/2 times 7 times 18. Or that can simplify down to be 7 times 9, which is 63. Sine of 143. And we can type that in the calculator. 63 sine of 143. Make sure you're in degrees. 37.914. Our angle was given to us in degrees. We need to make sure our calculator is in degrees. 37.914 watts. Meter squared. And that's all we were asked for on this one. We weren't asked to finish solving the triangle. We weren't asked to do anything else crazy with it. Just find the area. Questions on this first one using it? Okay. Next one, we've got triangle PIG. The triangle symbol doesn't like to show up every now and then. Triangle PIG. We've got measure of angle I, measure of angle G, side I, side G. So we have a lot of information here. So I'm going to draw some pictures so we can see what we've got. P-I-G. Making it a random. Remember, we're not drawing to scale. We're getting it close. But by drawing it out, sometimes we can see what pieces we have. Because we know angle I is 40. We know angle G is 81. I know side I is 4. And side G is 12. And we have been asked to find the area. To find the area, we need an angle and two sides that touch it. Because our formula for our area is our 1/2 AB. What's up? Oh, yep, it is side G. Sorry. I rewrote it wrong. Side G is 12. What happens when I read from this hard of an angle? So we need to have an angle and two sides that touch it. Now that I've put everything in the right spot, do we have an angle and two sides that touch it? Can we find an angle and two sides that touch it? Yeah. Triangle sides. So let's find out angle P. We know two of the angles. Let's figure this dude out. We know that all the angles in a triangle sum up to be 180. So we know that angle P, I'm just going to call it angle P, is going to equal 180 minus 81 minus 40. So what is the measurement of angle P? 59. So now I have a side and angle side. We have to have side angle side in order to be able to use our area that we have here. So we're going to substitute in those values. Our area is going to be 1/2. One of the sides we know, which is 4. The other side we know, which is 12. Dang, I know, gosh. And sine of the angle between them, which is 59. That sounds terrifying. How about we stop texting right now? Even though somebody's address is somewhere. Yes, I could hear what you were saying. You guys are bad at whispering. All right, so we've got 1/2 times 4 times 12, which means we have 24 sine of 59, and we can type that in our calculator. What is the area of triangle PIG?
20.572.
Say it again for me because I did it wrong in my notes.
20.572.
20.572. Because I mislabeled my sides exactly the way I mislabeled my sides up here in my notes. So be careful when you're labeling your sides. So what is our unit here? Inches squared. So make sure we are labeling our sides correctly. Make sure we're being careful, being organized, because it can really toss off your data if we label our sides wrong because they're moving too fast. So we can find angle now if we know side angle side. That's great. We aren't always given side angle side though. So we have another way to find area, which is called the Heron's area formula. And we can use this when we know all 3 sides. So this is used with side, side, side. So just like we had a cosine, a law of cosines that we used with side angle side, and we had a law of cosines that we used with side, 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 our area formulas work in the same kind of groups. So Heron's area formula has this new term S. So it's the square root of S times S minus each of the signs. And what S is called the semi-perimeter, or half the perimeter. How we figured this out, I don't know. But like, imagine being that bored. Holy cow. What's up? To Pythagoras?
Yeah. Why is it here?
Oh, because Pythagoras didn't find this out.
Oh.
He didn't figure it out. He figured out a whole lot of other stuff.
But
But Pythagoras did not figure out this area formula. This was a dude named Heron.
He named it after himself.
Yeah. That is why a lot of formulas, theorems, and like science stuff is named super weird. Because it's named after dudes who use their names, and oftentimes their names are weird. Like if I discovered a math theorem, it would be the Bieshki theorem. Which, y'all don't want me to figure something out that hard, because then everybody has to learn how to say Bieshki. There's very few scientific discoveries that are not named after people. Lately, people have started to do like Bodie McBoatface style namings on things. I think there's an element or some sort of scientific thing recently that was named after Sonic the Hedgehog. But I can't remember if it was an element or a formula or something. It was something about speed, or it was a very fast element. But yeah, for the most part, they're named after themselves because they want the fame. And this is as close as you could come to famous in the math world. It's naming a formula after yourself. All right. So we're going to practice with this because it's a little awkward. We have to find our semi-perimeter, and then it's the semi-perimeter, and it's then times semi-perimeter minus each of the sides. So we're gonna have a triangle that has sides 14, 21, and 27. And this is one time when I don't think that a picture is particularly helpful. It's not gonna hurt. If you want a triangle, feel free, draw a triangle. It's not particularly helpful when we're finding perimeter anyway. What we're gonna start with our Heron's formula is we need to find S. We need to find that semi-perimeter. So that means I find my perimeter, which is when we add up all the sides, 14 plus 21 plus 27, and we're gonna divide it by 2. That's what we mean by semi-perimeter. Take the perimeter, cut it in half. So our semi-perimeter here, S, is indeed 31. Then we're gonna take our Heron's formula. Our area is the square root of S times S minus A times S minus B times S minus C. And we're going to substitute all the pieces in that we have. So our area is the square root of our 31. Then we're going to do 31 minus 14. (31 minus 21). And 31 minus 27. So we grab all those pieces and substitute them in. And if we are super confident in our ability to type things in the calculator, you can just like go. But I know I'm not that good at typing inaccurately. So we're gonna simplify this a little bit. We're gonna have our 31 times 31 minus 14 is 17. 31 minus 21 is 10. And 31 minus 27 is 4. That is significantly easier to type in the calculator accurately. If we keep going and simplify it, we have the square root of 2180, or 21,080. Or what? What do we get when we simplify that fully? What is our area? Yep, 145.189. What unit? Centimeters squared. So they're weird, they're awkward, they're strange. They're not super difficult calculatory, but the formula is weird. Questions on this first one using Heron's? Okay. Now we're going to do a triangular goat pen that has sides 23, 19, and 27. 23, 19. Signs of spring. The lawnmower. The lawnmower. Signs of spring. All right. So the first thing we're going to start with is finding our semi-perimeter. So our semi-perimeter, we add up all of our sides. We're going to have our 23, 19, and 27, and then we divide them all by 2. 34 and a half. So our semi-perimeter is a decimal, and that's okay. 34.5. Now we're going to use that to fill in our herons. Area equals. So we start with having our S all by itself. So we're going to have our 34.5. Then we set up our little subtractions. So we're going to have our 34.5 minus 23. $34.5 minus 19. And 34.5 minus 27. Hey, but it's barely, but it's there. And we're going to simplify this as much as we can. The more we simplify in little pieces, the easier it is to get things right. But also, we can also type the whole under the radical in and simplify that in one go. Because it's decimally and kind of gross. We should wind up with our square root of 46,122.1875. Bruh, proud of you. Bruh. You said bruh, I did it. I'm just gonna say, next year, it's gonna be a really hard detox because the state legislature just passed the you don't get to have cell phones in school law. Mm-hmm. Starting next school year.
Luckily, I got my best friend.
You won't get to have your cell phones in class. Like it won't be, like actually on the desk or in your pocket. Like it's gonna have to be in your backpack or in your locker.
They gonna fill my pockets or what?
No, you're just gonna get. I have no idea how enforcement's gonna go. Literally it got passed like yesterday.
Oh, I seen that.
Yeah. Yeah, the governor just wrote it into law. Not on my TikTok. I'd be surprised if it doesn't hit your guys' at some point. I don't know. But, you know, it's a problem. So our area,
How are we gonna use calculator?
your phone is literally sitting next to a calculator. It is less than an inch away. I'm like, what do you mean? There's one up
He's
here.
been using his phone though.
Yeah, not on the tests. So our area is going to be 214.76 square feet. It's like they're going to have to be careful of their wordings, though. They did kind of also outlaw laptops. Technically, in the law, it is personal communication devices.
You gotta work with her.
Yeah?
I know for free.
Yeah. So you really only have one more problem in this section. And it's not worse. It's very similar. Spiral or composition?
Spiral.
Oh, I'm not a fan of composition books either. But last year, people asked for composition books like constantly. So I have a bunch of them now. And this year, I don't think anybody has wanted composition books. Strange. It's okay. Everybody will like them. Somebody will like them again. They don't go bad. All right. So this is actually our last problem in law of cosines. So we're going to find the area of an equilateral triangle with a perimeter of 21.3. And this one is not different than what we've done. There's just a couple of things in here that trick us up a little bit. Because what is the length of a side of this triangle? Divide by 3. So each side is how much? 7.1. And since it's equilateral, they're all the same. So in order to find our area, we still need to know our semi-perimeter. Well, this time I know my perimeter is 21.3. And to get my semi-perimeter, we divide it in half. So the semi-perimeter is going to be what? It's 10.65. So when we go into Heron's to find our area, I'm still going to write the whole thing out. So we're still going to have our S being 10.65. Then we're going to have our 10.65 minus 7.1 and 10.65 minus 7.1 and 10.65 minus 7.1. The instinct a lot of times with something like this is to make it 3 times, because we've seen it 3 times, but they're multiplied times each other. It's cubed, not 3 times. So that'll be the most common mistake I see on the equilaterals, is we try and make it 3. 10.65 minus 7.1. And that doesn't work. It's got to be cubed. So if you want to write it more economically, you can. Totally fine. Just make sure we're continuing this multiplying in between them, that they're multiplied against themselves. That's why I wrote it out the long way, so we could see that. Because what we have here is our 10.65 it's going to give us, is it 2.5? 3.5 cubed. And that's fine. You can write it like that. You can do it. Just remember it's cubed, not times 3. So what's our area? Get me down to the end of it. Is it 828 or 528? I can't read my handwriting. 828. My pen skipped out in the middle of the cross of the 8, so I can't. I'm like, I don't know. I'm just going to let somebody else tell me what the answer is. Feet squared. That's such a dead joke. Not the 10 pickles joke. Classic. Gosh, that one's a cringer. All right, so questions in our area stuff. Okay, because that's actually the end of section 8 too. So that's our law of cosine stuff. So it's on my to-do list today. Get the answer key for homework 8.2 posted. I'm more than halfway through it, but that'll get up today so that we can check our answers and things like that. Because as we can tell from the piles of stuff on your desk, I'm not great at handing stuff back in a timely manner. Because I think I handed stuff back from the first chapter of the semester for some of us. So tomorrow we're going to start section 8.3, which is a lot of very new stuff. So tomorrow is going to be very righty. Like we're going to have a lot of definitions. So the fact that we have a shorter day today is going to be good for that because like we're going to want to stretch out the hands tomorrow. We're going to have lots of writing. That's the end of section 8.2.
Oh, like in class?
Yeah.
Oh, I thought you meant.
No, not the day being shorter. But tomorrow we're starting a new section, and it'll be the first time you'll have seen many of these words. So we're going to have a lot of writing and a lot of definitions. The math itself is not complicated, but it's a different way of thinking about stuff. Okay? So we are going to have a quiz over law of cosines on the 27th, which is Wednesday. What's up? That will include area, yes.
Which is over 8.2.
Yes, section 8.2, which is the law of cosine section. And then we'll work with something called vectors. They alternate between logic and math. And it is, in fact, could be a math problem.